What? I'm not allowed to. But I need you to go see me on the next month.
I'll train you for spit.
What did you write?
What you got to trade? You just walk into your mom's place and just like clean them out and take whatever you want off the shelf. I think we can work something out, yeah. I think you and I can
Because I really need one. It's like killing me.
Okay, but there has to be, okay, you understand what opportunity cost is? You understand what opportunity cost is? Opportunity cost is the difference between like value and cost. So that thing cost me $3. And if we were going to do an even Steven trade for $3 a fish, you would get me like a little scrap that I can't really make much use of. But there's this thing called opportunity cost, which is I've got the burrito that you really want. And so the better question is, what's it worth to you? Like a pound of salmon? You know, if you had to pay for the salmon, you could get ripped off. But you've got fish at a highly discounted price, and I've got the burrito that you want hot on that plate right there.
That's so good.
Do you understand what opportunity cost means?
Yeah.
Because a straight trade is not in your favor, and I don't need a scrap of fish. You know what I mean?
Right.
Yeah, exactly. $3 of salmon. What is that? 1/7 of a pound? Yeah, that's pretty small. A medallion, a salmon cheek. So if you're down to actually waste salmon on me, yeah, game on. Yeah, okay, help yourself. Right there. Here's your burrito.
No.
I have to think about it.
Offer's always there.
And the burrito said
All right, children.
I'll think about it.
All right, children. Now that you've got your Petri dish, please look at it in the light. And chances are, you have a little hard water buildup there. If you don't, you can ignore it. But if you do, please rub the calcium deposits off both sides on the inside with this Kleenex, then pass it back. You can just with a t-shirt. You can use whatever you want.
Yeah. Calcium.
You can use t-shirt if you want.
Doesn't work at all.
Got my chainsaw? Oh, clever. Oh, did you find anything else in there?
What?
Did you find anything else in there that's of use?
You mean make the most noise out in the world?
In the left drawer.
Oh yeah, rub that calcium. Why are you doing Take a slice of newspaper towel.
tailgate, there's like two doors. The left one
It's a twice used tissue paper.
has a black piece of mesh. Here's my thing called the mesh. It says, give me one second. Next. Please allow me to demonstrate. This, in case you don't know, you can pretend not to know, it's fine, is petroleum jelly. AKA Vaseline. Watch this.
So jelly, do I can put it in my fingers?
Still waiting. On the inside only, on the flat surface only,
Stuff you put on like
you need to make a, fairly significant layer.
flat side.
On the top and the bottom, the interior only on the flat surface. These are particle collectors. The Vaseline will trap particulate pollution inside and outside of your home. Please look up. You'll put Vaseline on both, then you'll close it and pass to the person behind you the Vaseline. When they get to the last person in the row, bring it up to me.
Doesn't take that bad.
Oh my god.
Please look up. Label one of those in, and the other one label out. See how they say in and out? Using the Sharpie, doesn't matter which one is which. Label them in and out on the Petri dish directly. Then please look up. Grab at least a foot of tape. 1.5 feet is not a big deal. Please look up. You need at least a foot of tape. Label in and out. And then, look at me. I'm a rapper. Because I like to rap.
What are we doing?
No success?
No, it's fine.
In a Ziploc bag? For real?
Yeah.
Yeah, sorry, bro. I could have sworn there was something. Okay. Please look up. Okay, let's stop talking. Has nobody caught on that I'm trying to give instructions, or is it just Bela that doesn't care?
I don't understand.
In on one side, out on the other, at least a foot of tape wrapped around. Then put your last name and period on it. Like that. And pass back the tape and Sharpie. Remember, once the stuff gets to the back row, You walk it back to me.
You want us to do the Sharpie directly on the Petri dish?
I need your attention, please. I need your attention, please. Remember that while you're otherwise not doing this, you should be copying number 31.
No.
Jose, what does it say for like the static precipitator and
I just need to get on.
You need the Sharpie. Wait, I still need the Sharpie. I was supposed to grab that.
I don't know. Take what did you take? And back call.
Wait, is there
No.
in and out? What should I think? No?
Why? I don't know why.
Yeah.
This one, the white sand doesn't.
Maybe because the blended purchase
Too late. Are you sure that they're not reversed, maybe? Something else missing?
I don't know. Angus gave it to me. Deal with it.
Was it putting some controllers jelly on this?
Students, you would not believe how many times I have heard students asking what the next step was. And I fear that's because they were talking when I gave that step out. Please listen carefully. When you get home, you will prepare 2 separate particulate pollution collectors. I gave you already about 1.5 foot of tape. Please look up. You'll take that tape, tear it in half. You'll take that tape and tear it in half. Please look up. You can stick it to itself to get the back. And if you need to, you've got a little tail to put it on the surface and wrap it around, or put it sideways, or whatever you need to secure it.
What?
Please be quiet. You will go home, open the two different halves, use that tape to make sticky. Are there questions about that? Then please be quiet. Find a high traffic environment, one indoors, one outdoors. You've got the in and the out for indoor or outdoor. High traffic outdoors might be like the entryway / gate for your house. High traffic indoors might be something like probably your kitchen or something like that. Hallway, entry room. Find a high traffic indoor and a high traffic outdoor environment. Please plan for rain, so don't leave it out where direct rainfall would fill the dish. Please plan for wind. So if it's a windy spot, shelter it with a rock or something like that. Please plan for your house servants / your parents. Like maybe a little post-it that says, "Don't throw this away, my science experiment, signed school kid." Please think ahead. You'll leave it open until Monday night next week. Then you'll use those pieces of tape to bring it shut on Tuesday, the 24th of March. So it'll be up 7 days from today until Monday night. Yeah.
Can we put on something moving like a gate or a cabinet door?
If you think you can secure it to something which moves, that's fine. What else? Yeah. Usually you get better results when it's like this, but if it's sideways, it's okay. You'll notice significant differences. So this traps about 25% of what this traps.
Okay, and then do you not suggest places that are dusty? Or
What's that?
do you not suggest places that are dusty like on the shelf?
Actually, what I'm looking for is high traffic. So that's usually where dust gathers. The dustiest places is where you have the most air movement. Yeah.
Is there anything we should do if our potassium iodide strips are moldy?
They're all moldy. What else?
How do you get potassium?
What? Are there any more questions? Are there any more questions about the particulate collectors?
And put them upside down.
Wait, are they gonna get like gross?
They shouldn't get too gross. If the parents are dirt freaks, I don't know.
Like,
Give them
do I need
something.
to warn my mom not to get it?
What?
Do I need to warn my mom not to get it?
I don't know. Maybe. You know your mom better than I do. It'll pick up dust.
The what?
Well, I mean, I'm not gonna hide it in my mouth.
No, give it one day. I don't want this sharpness.
Next. Next. You have a Ziploc bag with 2 moldy strips of coffee paper. Listen very carefully. Those moldy strips of coffee paper, when you get them wet, will react with ozone in the air. I'd like you to find the largest electronic appliance in your home. That's almost always your fridge. But if you have a big old computer, if you have a big old television that's used a lot, if you have a large grow room, pottery project, computer server, find the single largest electrical appliance in your home. Hilo, can you stop talking, please? Talking you too, please. For 8 hours only, you're going to test for ozone. To do that, you have to get that strip wet. You can just soak it in water. Hang it for 8 hours. Away from UV. And after it has been in the air for 8 hours without any ultraviolet light, you'll put it back in the bag. And at that time, you ask your phone, what is the humidity here? What is humidity here?
Here is what I found.
What is relative humidity here? That's where it works. Oh man. What is the relative humidity here now?
Here's some information.
I swear I just did this last period and it gave me the humidity. I swear I'm not lying to you. What is current humidity here?
Your humidity index is currently 66%.
There we go. You can use any sort of web service to find current humidity index. And after you put the strip back in the bag, you'll want to write down what the humidity was at your sample site. Are there any questions about that? First question, Paul.
So if you're putting it, you put it in your fridge or like on the side of your fridge?
Oh, on the side and preferably behind.
And what about like,
Well,
can you do it overnight?
which thing overnight? The ozone collector? 8 hours. So if you can get it back in about 8 hours, that's fine. The time that it's exposed to the air is important. So if you go to sleep and you've got 8 hours, you'll be awake in 8 hours to get it. That's perfect. No problem.
Okay, also I can't get behind my fridge.
Can use a different appliance. You might have a little vent right above it. If you look carefully, it's built into your cabinetry. See if there's a little metal grate right above your fridge.
Yeah, I reckon it on.
Put it right there. Both strips right next to each other.
Can we tape them on?
You can use a clothespin or a thumbtack. If you're going to tape them, don't get it wet on the spot where you tape it. So if you're going to use tape, like apply the tape first, get it wet right up to the edge of the tape, and then tape it on.
Okay. And then, when should we measure the humidity? Can we do that all the time?
What?
When should we measure the humidity?
When you're putting it away. What else? Yeah.
So if you're gonna like do it on like a TV or something like that, do you want to stick the tape right onto the television, or do you want to put it like near the television? Or, like,
Technically, all these appliances generate the most ozone where the vents are. So in this case, I would stick it just behind this monitor. On a television like this, I might try to get up on top and tape it on the back edge of the rim. Just so you know, this is kind of an imperfect science, and we're just going to take our best chances. But the place where you're going to get the best results or have the best chances of getting any results will be where the gases are leaving the electronics. FYI, the mold should not be relevant, but it's going to get moldier. Make sure you keep it away from ultraviolet. So put it into your backpack, and you only take it out for those 8 hours, and then it's back in the bag, back in the dark. Any more questions for me? Yeah.
Thank you.
So we're doing just one of them or both of them?
Both, unless you only have one.
And when is this due?
Both of these are due on Tuesday the 24th. 24th. Tuesday the 34th. Question?
Do we put them on different appliances or the same?
If you can keep track of which is which, that'd be cool. Different would be cool. Yeah.
This one does it matter if I do it tonight or like the night before?
It might be better to do it the night before just to minimize moldiness, because when you get it wet again and you put it back in the bag, it'll go through a second round of molding. Shouldn't matter, but we want to like try to keep them getting too moldy. Yeah.
Everybody needs to make sure they keep the bag sealed, because if you leave it open, it'll start to react.
Are there any questions about either of these two air quality tests? In your home, you'll be able to measure the levels of ozone and particulates. Anybody have any questions? Make sure that you've finished copying number 31, and of course that you put away your cell phones game well. Who has my last Sharpie? I'm glad that you've used your half hour of class so far to copy this stuff, because we're going to go pretty fast.
Haha. Haha.
Oh, wait, you have it. Oh, wait, your name is Bodie and you don't use paper. Don't worry, bro, you don't need to fake it. You're not fooling anybody. Okay. Okay. Step back to yesterday. All rain is acidic, but locally, where you have NOx and SOx, it becomes more acidic. A localized problem, cumulative effects. Please look up. If the SOx occur with fog, and that stays where the people are, you can get London-type gray sulfurous smog, which is basically cold emissions making acidic fog. In LA, there's a different type, which is brown, called photochemical, because chemicals from vehicle emission plus sunlight can make a toxic group of oxidants, like ozone or PAN, which is a big category of chemicals that includes an NO2 at the end, resulting in a very loosely attached oxygen. Those oxidants are dangerous because, like free radicals in your bloodstream, they can kind of tweak chemistry. Yeah? I'm sorry, say it again, please?
Vehicles give out NOx.
They do, yeah. You can remember that 200% elevation in NOx and 200% in SOx from cars and coal. Now here's the good news. In Santa Barbara, even if we had NOx and VOCs and SOx and H2O, we would not get smog. Did we talk about inversion layers yesterday? I found another way to draw that which might help you, and if it doesn't, ignore me. But in case this is helpful, please look up. This is normal. Where the ground is hot, so the hottest air is near the ground, and as it rises, it cools. This is normal. Less common.
The C is on the blue side.
Oh. Red is hot, blue is cold. So as you go up, air gets cooler and cooler and cooler until it's really cold at the top. This is like the air conditioning control on old Volkswagens. Then please look up. In an inversion layer, yes, the ground is still hot, but watch what happens. Hot air rises from the ground until it hits a glass ceiling of hotter air. That hotter air will prevent air pollution from rising because heat is high pressure. So you'll get like this, where cold air in and hot air over traps the pollution from cars, factories, and homes. And here's an important detail that some of my students don't quite understand. It's not just that this creates two types of smog, but anything which was found in those gases would not... James Mellick, you're covering the cell phone. I swear to God, I'm going to go back and kill you. Okay. The hot air goes up and cannot get any higher because there's even hotter above it. So like smoke from a forest fire, pollen from pine trees, dust from construction, whatever is in that air mass will not go higher. Like this glass ceiling. You can see it. Did I show you the pictures of smog yesterday? Like those? In the case of Los Angeles, please look up. It's because as the sun rises, LA is in the shade and cold marine layer while the desert gets hot. So in the morning in Los Angeles, you create the inversion layer because the desert had about 2 hours of sunlight before the city had sunlight. Does that make sense to everybody? Yeah.
I'm still confused as to why Santa Barbara doesn't have an inversion layer. It seems like the perfect condition for it.
Well, for one thing, we're not trapping air. We have lateral movement. Our range is roughly continuous that way and this way. You know, we do have like the Mesa and the Front Range, but our winds kind of scoop up and down shore. We've got lots of places for stuff to dissipate.
And the sun doesn't like rise.
Yeah, and the sun
Desert.
doesn't really favor the desert. Our mountains go north-south. These are east-west. So pretty much when the sunlight hits us, the sunlight has hit Los Olivos. There's a few different ways you can build this. In LA, it's just the circle of mountains and the desert. But in Mexico City, it's just a bowl up high. So sinking cold air just sort of settles, and the desert heats up before the city, so it traps smog like a bowl of cold air. Denver, Colorado, the city is surrounded by big snowy mountains, so at night cold air sinks and fills in that city basin.
I was just there recently and I saw, you can see the inversion.
There's a bunch of different ways that you can get hot air and cold air. Essentially, you need a place where that cold air can settle and then a source of hot air nearby. Because it's hotter, it expands over the cold air. You know, high pressure spreading to low pressure. Yeah?
So why can't the hot air like layer rise even more?
You can imagine that it does, but you still get what's called a thermocline. It's a really, really sharp line where hot air will not sink, but it will spread. Over really long distances, it gets fuzzier and dissipates. But especially near the source, like those mountain ridges, it will pretty much spread perfectly flat for a good long distance. It is, by the way, rising from that, but as long as you've got a heat source, it's still going to make that shelf. Because these areas will trap whichever pollutants are present. In London, the way that they get this is because in London the city's surrounded by water, and you get these breezes that come off the ocean over the city because it's near a big channel. So you know that channels have like channel tide, and you have cold air sinking out of the mountains along the riverway. So because London is surrounded by water, it just has cold air that washes over the city. Same effect. But in their case, it's got this chemistry. Since you can't really change an inversion layer, the best you can do is change the pollution. So please look up. We've got 3 stars for different types of pollution controls. I hope you can see how I've organized this, and if you're in the back, it might be hard to see the bottom. Please look up. Particulates, SOx, and sometimes other oxidants, and cars down below. So we've got particulates, SOx, and cars. How many of you have already drawn as much as you could of the particulates? Okay. This is for factories and power plants. In case you couldn't read, that says smokestack, filter baghouse, cyclone, and 2 big words, electrostatic precipitator. I'll explain. Back in the day, factories didn't even have chimneys. But you can imagine, a stack of bricks is probably cheaper than retraining new staff. So rather than have your factory fill up with toxic smoke and all your workers living nearby dying early of health effects, factory owners realized that if you just pile up some bricks on top of the roof, that hot air rising will draw the pollution up and then dissipate it into a higher altitude. So the very first type of pollution control, going way, way, way back, was a pile of bricks on the roof, called a smokestack. That's why it's a stack, by the way, because they used to just stack bricks. You can also call those flues or chimneys. I think everybody knows. Does everybody know those 2 words? Flue? F-L-U-E? You might want to write that down. A lot of A lot of builders call them flues. Next, like an old vacuum cleaner, you can just use a filter where you push all the particulates through a big filter bag. Please notice, both of these names are the same concept. The filter is the bag house is the structure where the filter is. Does everybody know how filters work? It's like a mesh, sort of like catching fish with a net. The water pours through, but the fish is in the net. So you weave a fabric that you can let the air pass through, but not the particulates. Everyone understand that? Has anybody seen an old vacuum cleaner that had like the zipper and the bag, and you can take it? Cyclones force the air to whip around, and as that air moves, it gets the particulates stuck in those wedges. So the air that comes out is clean. This uses centripetal force. They're called cyclones or centripetal capture. You guys know centripetal force? Like whip a bucket around, keeps the water in the bucket. So by accelerating the air, all the particulates go out to the outside. Yeah?
Wait, for the smokestacks, isn't the air that comes out not clean?
That's right, but at least you get it further from people, and that's a big improvement.
Oh.
So in the very first, like, 1700, I don't know, early factories, what were early factories? The earliest Industrial Revolution days, all the first iron work, it was all done in, like, open pits. Like, people would just throw coal into a hole, and they would, pump it up, and then they would just work the, like, and then they realized, like, oh, if I put a chimney on this, my workers last longer. This one confuses my students. Follow closely, please. Does anybody know how static cling works for like clothing and hair?
It's like the negatively charged particles in an object will stick to the positively charged particles in another object.
Yeah, basically. And then you use friction to line them up. And it's kind of a mystery. I think it's called anybody know what's called Thiebaud electric? Let me get the right term. I highlighted this morning because I wanted to get it right. Here we go. It is the triboelectric effect, which is Greek for the, get this, rubbing effect. You know when you rub a balloon across your hair and it makes your hair stand up? Or if you like toss your clothes in the dryer with very minimal heat differential, they stick to you, static cling. This is the same concept. This is the part where you must see this. You use an electromagnet to apply a charge. Then you trap the particulates with an opposite charge here. So look, as the particulates rise, this box, electromagnetic, applies a charge to the particulates. Basically like static cling. You just whip an electrical current through there. That makes all of your particulates have a charge, like shirt that's going to stick to you later. You induce a charge into the particulates. You apply a negative charge to the particulates. Then those pieces of dust or ash or whatever are trapped by a magnet with the opposite polarity. I want everybody to keep in mind, like, was it Gabby or Sarah who pointed this out? This one just moves the stuff further. Just gets it away from the workers. And these, the baghouse, cyclone, and precipitator, those just let you contain your trash. Yeah?
What's the most effective way?
This one takes a lot of work. it takes a lot of energy, so electricity cost might be a problem. If we had sustainable electricity, it'd be a no-brainer. These are really, really effective, but as soon as they start capturing particulates, there's less airflow, so they become less effective. So there's methods of filter houses that have like a moving filter sock, like as you fill it up, it kind of goes into a conveyor belt and a new section comes across. The secret with these is you got to clean out the bags really often. And these can be dialed for a certain size, but no matter what, these just separate sizes. This will always capture the biggest and always let the smallest go through. So they all have like downsides. I think for sawmills and stuff, they use these for sawdust or for like wood shavings, and then they'll have one of these for the really fine stuff afterward. Not everything picks up a charge equally well. For ashes, I think these are better.
Is the electromagnet always negatively charged, or not?
No, and I just kind of took a stab at it because it was easier to draw negatives than positives, but it might be the other way around. You apply one, and then you always trap it with the opposite.
It just doesn't really matter.
And maybe it matters, and I don't know which way. All I know for sure is you apply one charge, and then you trap with the opposite. Yeah.
Okay, so you're saying all of them get the particulates away from people, but the last three separate the particulates in the fresh air.
That's right. So in this case, you can put it in the landfill. You know something cool with coal ashes? You can pack them and then burn it again. Because ash is unfinished burning. Yeah.
That big green machine by the wood shop class,
Is one of these followed by one of those. You can see both of these when you walk down to Mad on over the window of the wood shop.
That was making so much noise all the time.
There's a big old fan that has there's tubes all through the wood shop that are just like big suction tubes, and that goes into a cyclone and filter house. There's two separate boxes. What else? Great.
Wait, what's the last one? Which time is it?
Electrostatic precipitator?
No, it's in one more.
Oh, and wait, there's one more coming soon. Is that what you were asking? The next one, the next type of filtration is to get rid of those oxides. Here we trap particulates, here we trap chemicals. Remember that SOx, that's a gas. Like oxygen, how would you grab oxygen? So grabbing SOx is kind of difficult unless you use chemistry, like this. This says, mix oxides and water in the smokestack so you can collect acids where you can control them. It works like this. Smoke with SOx goes into the scrubber. Please look up. Shower heads spray water on the smoke, and then you collect all of that sulfuric acid down here. In other words, to trap this gas, you spray water to make it into sulfuric acid in the factory or in the power plant. Again, you mix the oxides and water in the smokestack. So you can collect acids where you can control them. So you just spray some water over the smoke, water and SOx mix together to make sulfuric acid. And here's a bonus. Sulfuric acid, if you have it in a big old jar, is kind of valuable because you can mix it with really cheap limestone powder to make gypsum, which is a valuable ingredient in concrete. Places that do this, if they can get cheap limestone, can make money by filtering the SOx out of their smokestack. That process is called scrubbing, or a longer term, flue gas desulfurization, because you're taking the sulfur out of the gas in the chimney. Yeah?
Does that say like H2SO1 or?
It says H2SO4. You've done this chemistry in the flue. What else? You can probably imagine that spraying the shower into the smoke also traps particulates. This was the one left. We'll have to talk about cars tomorrow. I just want to make sure that there's no questions left about particulates and SOx. Any questions about life or about the testers? Yes?
I have questions about that assignment.
Say what now?
The assignment you told us they were going to do today.
So what was due today, I have moved to Tuesday the 24th.
Oh, so that's what this is?
That's what these are.
Okay.
Same day.